Bismillahirrahmanirrahim. This is a digital inverted pendulum practical. We are having all the setup here. This is computer, and where there is a Simulink model for the inverted pendulum and for the crane PID as well. Here, this is the rail. You can see here this is the rail on which the cart can move. And these are the pendulums. We are having a pair of the pendulums. This is normally in this position, in a downward position. Similarly, it can invert in the upward position here, and it would try to stabilize like this. Okay, this is a 2 degree of freedom, and so we can simultaneously control both the position of the cart and the inverted pendulum as well. The first practical, we will control the position of this cart, and this cart will follow the sine wave. We will simulate this. Similarly, we are having the DC motor here, the same DC motor. This is the controller. This DC motor controls the position of the cart as well as the position of the this inverted pendulum by giving impulse to the cart, and the pendulum will invert just like this. There will be impulsive force on the cart, and that will be provided by the DC motor, and then the pendulums will invert. So this will be the inverted pendulum, and that how it can try to stabilize in the upright position. Okay, this is how we can do it in Matlab. This is the Matlab Simulink model. Let me click on the crane PID in the Matlab. So this is the model for the crane PID. Let me simulate this model. Tools, real-time workshop, build model. So here all the code, all the block diagrams which are written in the C program, that will be converted to the executable machine code. Yes, successful completion of the real-time workshop. Now we will simulate. We'll run. So this is the Simulink model. You can see here. Control system. This is the whole PID cart, PID for the pendulum controller, and some associated circuitry. We are having a differentiator here. So this is the controller part. Let me connect the model, and the simulation will start. The simulation will be shown on the scope. This is the scope. Let me start the real-time simulation. You can see here the cart is moving, and it is following a sine wave. So yes, this is the scope, and you people can see it, the desired position, One is the yellow response and the other is the purple response. Let me simulate it again. The time is out for the simulation. Again I am connecting here. I am starting the real time execution of the lab. Yes, the cart is starting. The cart starts. It is following the sine wave, which is shown here on this here. So you can see here, this is exactly following. One is the input, the sine wave, the purple one, and you can see here the yellow, that is the response of this card. So this is exactly following the input sinusoidal signal. Similarly, we are having the model for the inverted PD here. This is, you can see here the title of the inverted PD, and this is the model for the inverted pendulum. Here the pendulum will invert, and we people can see the position of the inverted pendulum. You can see here, this is perfectly in the upright position, the inverted pendulum, and this is a very good response. It's a very perfect response. And now the time out. Similarly, we are having the twin rotor MIMO system. This is a helicopter. This is the tail rotor of the helicopter, which moves horizontally. This is the main rotor of the helicopter, or the twin rotor MIMO system, which moves up and down. This is the Simulink model. Here, this is the PID controller. This is the controller part. PID for the rotor and PID for the tail. Here you can see here different values of the Ki, the Kd and the Kp. So I'm going to execute. The program is simulated before, and I'm just start the execution. So here goes the light. The lights, it is just, there is a shutdown of the electric power.